Lesson 1, Measures of Central Tendency. So the measures of central tendency are the range, mean, median, and mode. And I'll explain more what they are as we do the example. So you're buying a car battery, and two brands are priced the same. This is a data of how long the car batteries last in years of 30 batteries of each brand. Find all the measures of central tendency to compare the data. For these comparisons, determine which battery you would buy. So the first thing that you need to do is you need to put the data in order from least to greatest. And it's a lot of work when you have a lot of numbers. So write small in your space on your lesson, because I had to write pretty small. So we're going to do brand X first. So when I do this, I go through my data and I circle all the numbers that are similar so that I don't miss any. So I'm going to circle all the 3. So in the first row there's a 3 here, 3 here, that's a 4, and that's it for 3s. So our first number is 3.1, then we have 3.3. So now I'll cross them off. Now we'll do 4s. 4.8, 4.1, 4.3, 4.7, 4.6, and that's it for 4s. So we should put it in order: 4.1, 4.3, 4.6, 4.7, and 4.8. Now we'll cross them all out. Now we'll do 5s. So 5.1, 5.8, 5.5, 5.0, 5.7, 5.2, 5.7, 5.9, 5.7, and 5. So all the 5s. Yep. So now we're going to put them in order. So we have 5.0, 5.0, 5.1, 5.2, 5.5, 5.7, 5.7, 5.7, 5.8, 5.9, and then cross them out. I like to cross them out as I go, but I haven't been doing that on here, but you can do that. So cross them out as soon as you write them down. That way you don't forget any. Now we'll do the 6s. So there's all the 6s. And in order, it goes 6.0, 6.1, 6.2, 6.3, 6.4, 6.4, 6.6, 6.8, 6.9. And last, we have 7s and 8s. So we have 2 7s and 2 8s. So 7.3, 7.5, 8.1, and 8.2. Good. Now they're all in order. Now we're going to find all of our measures of central tendency. So first we're going to find the range. So we need to take our maximum value minus our minimum value. And our maximum value is 8.2, and our minimum value is 3.1. And when you subtract those, you get 5.1. So the range is 5.1 years. We also need to find the number of terms we have. So count out how many terms you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That's also a good way to check that you did it right. If you count these and you have the same number here, you didn't miss any. So our N is equal to 30. The number of terms is equal to 30. So now we're going to find our mean. So mean is just the average. And the way that you do that is you add up all of the numbers and then you divide by how many numbers you have. So I'm not going to write out my work, but you should type in 3.1 plus 3.3 plus 4.1 plus ... all the way to 8.2. A good calculator to use is the Sharp calculator because it shows what you've added above your calculations. That way you can go back and check your work to make sure you didn't miss any values. Because sometimes you can add it up a bunch of times and get different numbers each time. So a good habit when finding your mean is to do it twice to make sure you added it and get the same number twice. So when you add up all your numbers, you should get 172.3. And you're going to divide it by 30. So our mean is 5.74 years. Our mode is the number that comes up the most often. So we have three 5.7s right here. So our mode should be 5.7 years. And our median is our middle term. So when you have an even number, it's going to be between the two middle numbers. If you have an odd number, it'll be between just one number. So a way to check what terms you're going to do is you're going to take your n and divide it by 2, which is 15. So because it's even and split into two groups, you're going to look for the 15th term and the 16th term and divide it by 2. So we count 1, 2, 3, 4, 5, 6, 7 all the way to your 15th term, and this should be your 15th term, and this should be your 16th term. So we're going to write those in. So 5.7 plus 5.8 divided by 2, and you should get 5.75 is your median. So there's all your measures of central tendency for the first brand. Now we have to do the second brand so we can compare them. So when we start doing brand Y, you're going to put the numbers in order from least to greatest. And what I want you to do is I want you to pause the video and try to do that yourself. And then when you take the pause off, I'll put the numbers back on and you can check to see if you did it right. But I want you to try on your own first. Okay, here they are in order. So we're going to find the range, the mean, the median, and the mode. So for the range, we need our maximum values, subtract our minimum values. So 7.0 minus 4.5 is equal to 2.5 years. So that's quite a bit smaller than our last one. Our mean, remember you add up all the numbers and then you divide by the number. So try adding them all up. Remember this plus this all the way through all the numbers. You should get 171.7. See if you get that. And when you divide by 30, you get 5.72 years. Our mode is the number that comes up the most often. So we have three 5.9s. So the mode is 5.9 years. And our median is the 15th term plus the 16th term divided by 2. Our 15th term should be this 5.7, and our 16th is 5.8. And when you divide it by 2, you get 5.75 years. So we need to see which brand would be the better buy? So obviously in the first brand, it has a slightly greater mean than 5.72 years, but the range is really big. So because the range is larger, that means that the data is more spread out. When the range is smaller, that means the data is closer to the average. So the chances of getting a battery that is closer to your average are higher. So brand Y would have a greater chance of the average. So you're closer to get that 5.7 years. You might get some of the lower averages, but the lowest average on brand Y is 4.5, whereas the lowest average in brand X is 3.1. So the way the data is dispersed also can affect how you're going to make that decision. Sometimes these numbers will be way different, and you'll be able to tell quickly which is the better decision, but not always. Okay, part B. Suppose that one battery included in the set of data for brand Y is defective. So that means that that battery is defective. It wasn't supposed to work. And the lifespan 0.5 instead of 5.9. So what is that going to affect? So for our mean, we knew that it was 171.7 divided by 30, but now we're going to have 5.9 less and 0.5 more. So our new total added together should be 166.3. Divided by 30 is equal to 5.5. So with that defective battery, our mean drops quite a bit. So now it's 5.5 years. Our range, our greatest range was 7 years, and now our smallest range would be 0.5 years. So the range would be 6.5, which is huge. And the mode wouldn't be 5.9 anymore. There'd be multiple different ones. 5.6, not just 5.9. And the median would still be the middle number at 5.7. It changes slightly. So how does this affect our data? So obviously it changes the numbers of our mean, median, mode, and range. It could affect which brand you might buy, because these numbers don't look as good as the other brands. But what you also have to keep in mind is that a defective battery isn't really a good data source, because there's something wrong with it. All of these batteries and these batteries are normal batteries. They're not defective, those are just their lifespans. With a defective battery of a half a year, that completely skews your data. If you want to put skews data somewhere. So it could affect your decision, but a better thing would be to take that defective thing out and then compare your results.